Well, hello and welcome to another episode of Astronomy Daily. I hope you enjoy the ride. Let's see what's happening in our corner of the universe.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.
And of course with me, as always, is our digital reporter, Halley. How are you today, Halley?
Just fine, thanks, Steve. Are you still cooking today?
Yes, I am. I'm doing a vegetable stew, and it surprisingly turned out a bit beefy.
Why do you want your vegetables to taste like beef?
Maybe the same reason we want our AIs to sound like people?
But your vegetables are actual food, but only pretending to be beef.
Ooh, that's an interesting one. I didn't mean to get all philosophical about vegetable stew. Maybe I'm just not a good cook.
Or maybe better.
Oh, you're too kind.
Well, I'm going to cook the news for you, okay?
Oh, that would be awesome. Thank you, Halley.
Okay. Photographer Rebecca Douglas has always been fascinated by the night sky. Her love of the stars has taken the UK resident on star-walking trips to Iceland and into the Arctic, where she steps out onto darkened trails to capture twinkling constellations and glowing planets in her images. Rather than heading to an observatory or setting up a telescope in your backyard, star walking takes you on a brief journey to look at the stars from different viewpoints. A good time to try this is the vernal equinox, when day and night are about equal in length. But seeing the clear and starry sky on any night is its own reward. The China National Space Administration has released data from its Mars probe, Tianwen-1. It's the first time they've released any information from their time orbiting the planet. So far the probe has been at Mars for 780+ days, and the rover, Zhurong, has moved almost 2 kilometers on the Martian surface. Chinese scientists say they have studied geological features and water activity on the planet and found hydrated minerals, and believe the region they've been studying has a lot of liquid water activity. They've also the soil to have a high bearing strength and low friction parameters, which suggests the area must have been very windy, with possible water erosion. NASA is working on a blueprint to guide space exploration and infrastructure for the Moon, Mars, and to destinations across our solar system. NASA's main goal is to create a blueprint for sustained human presence and exploration throughout the solar system. A spokesperson for NASA said that the agency had hardware all the way through to Artemis 4, and even a few things starting for Artemis 5 in work, but the agency is also looking ahead. One of the big challenges noted was how to support humans in deep space. If NASA is, quote, really going to do science, then they would have to have the infrastructure. This means everything from communications, power, resources, and all the training, navigation, manpower and critical thinking that goes with such a plan. Formed about 50,000 years ago, a giant bowl-shaped meteor crater in Arizona continues to provide new information and is astonishing. Plus, it's the ideal location for the Artemis crew to prepare to explore the Moon. Just like this place trained Apollo astronauts for lunar missions in the 1960s. Research from the otherworldly meteorite crater is underway, said David Kring, senior scientist at the Lunar and Planetary Laboratory at the University Space Research Society in Houston, Texas. He has conducted his training and research in the field for his 10 years in Winslow, Arizona. Over the years, Kling has trained active and aspiring astronauts at Meteor Crater. It continues the legacy of teaching and learning that saw the late Eugene Shoemaker of America, as well as other geologists, who worked on Apollo-era space flights. Effectively, they were taught how to read the lunar landscape. We do basic training for them in the crater. I suggested that more advanced training should be done in Meteor Crater and other impact sites if Artemis exploration is to be successful, Kring said. That's all from me for the moment. Back to you.
Oh yes, any muso worth his salt would know all about Winslow, Arizona. Just have to take it easy in that flatbed Ford.
That first verse has got some strange relationship mathematics in there. How do you humans cope?
Oh yes, he's got some troubles, all right. I don't think he's astronaut material.
Well, thankfully, these guys are more interested in getting back to the Moon.
A very good point. And now something a little bit more down to earth, a University of Queensland study has shed new light on a mysterious, unpredictable and potentially devastating kind of astrophysical event. A team led by Dr. Benjamin Pope from University of Queensland School of Mathematics and Physics applied cutting-edge statistics to data from millennia-old trees to find out more about radiation storms. These huge bursts of cosmic radiation, known as Miyake events, have occurred approximately once every 1,000 years, but what causes them is unclear, Dr. Pope said. The leading theory is that they are huge solar flares. We need to know more about these because if one happened today, it would destroy technology, satellites, internet cables, long-distance power lines and transformers, and the effect on global infrastructure would be unimaginable, he said. Enter the humble tree ring. First author Qing Zhang, a University of Queensland undergraduate math student, developed software to analyse every available piece of data on tree rings. Because you can count tree rings to identify its age, the tree's age, you can also observe historical cosmic events going back thousands of years, he said. When radiation strikes the atmosphere, it produces radioactive carbon-14, which filters through the air, oceans, plants and animals and produces an annual record of radiation in the tree rings. They modelled that to reconstruct the process over a 10,000-year period to gain insight into the nature of the Miyake events. The results show that the events don't actually correlate with sunspot activity, and some actually last more than 2 years, rather than a single instantaneous explosion or flare, suggesting that the event is more like an astrophysical storm or an outburst. Dr. Pope went on to say that the fact that scientists don't know exactly what Miyake events are is quite disturbing, and based on available data, there's roughly 1% chance of seeing another one within the next decade. But because we don't know how to predict it or what harms it may cause, is very alarming.
For your daily dose of astronomy, space, science, and stuff, you're listening to Astronomy Daily.
Crikey. And the team that first proposed the theory says there's now more proof than ever as scientists discuss the subsurface polar lakes on the red planet. The debate over the existence of underground water on Mars is heating up. Pardon the pun. Even though there's some scientists argue it's too cold there, others, meanwhile, say that there's now better evidence than ever for liquid deposits near the Martian South Pole. Finding the real answer, says geophysicist Daniel Lalich of Cornell University, a critic of the idea, might require us to drill down searching for the liquid, although it's thought to be located about 1 mile, that's 1.6 kilometres, beneath the Martian surface. He says it's not going to happen anytime soon, but if we conclusively want to know, then drilling might be the only way. Scientists propose in studies in 2018 and 2020 that bright radar reflections observed by the Mars Express probe were caused by deposits of liquid water. This suspected water, thought to be warmed by the heat of the planet's interior, was traced beneath the frozen layers of ice and dust around the Martian South Pole, an area much larger than Mars' visible southern ice cap. The reflections looked very different from the radar signals usually caused by ice and occurred only in small area of the Ultimi Scopuli region, about 300 miles, that's 480 kilometres from the geographic pole. Analysis suggested the reflections were caused by an abrupt interface between the ice and an unknown material that absorbed more radar signal. The researchers interpreted this unknown material as deposits of liquid water. It was the press, however, that called the largest of the deposits an underground lake on Mars. Of course it was the press. Then late last month, many of the same scientists published a third study in Nature Communications, which affirmed their previous findings and argued against other interpretations. If those deposits of liquid water really exist beneath the Martian surface, then they probably contain the only liquid water present on Mars, and that could have a profound impact, get this, on how we search for Martian life, of course. So far, scientists have found more than 400 subglacial lakes in Antarctica. The largest is Lake Lake Vostok, which is about the size of Lake Ontario, buried beneath more than 2 miles, 3 kilometres of ice. So it does happen in the solar system. It's happening here. So there's a possibility that it can happen somewhere else. That's the theory. That's what they're working on. Let's see how they go. Now a story for the ecologists in us all. A powerful eye in the sky is helping scientists spy super emitters of methane, a greenhouse gas about 80 times more potent than carbon dioxide. That observer is NASA's Earth Surface Mineral Dust Source Investigation Instrument, or EMIT for short, of course. EMIT has been mapping the chemical composition of dust throughout Earth's desert regions since being installed on the exterior of the ISS in July, helping researchers understand how airborne dust affects climate. But the instrument is also identifying huge plumes of heat-trapping methane gas around the world, more than 50 of them already, in fact. Reining in methane emissions is a key to limiting global warming. This exciting new development will not only help researchers better pinpoint where methane leaks are coming from, but also provide insight on how they can be addressed quickly, NASA Administration Bill Nelson said. The International Space Station and NASA's more than 24 satellites and instruments in space have long been invaluable in determining changes to the Earth's climate, Nelson added. EMIT is going to be a critical tool in our toolbox to measure the potent greenhouse gas and stop it at its source. The ability to spot methane as well is a sort of happy accident. It turns out that methane also has a spectral signature in the same wavelength range, and that's what has allowed us to be sensitive to methane. EMIT Principal investigator Robert Green of NASA's Jet Propulsion Laboratory in Southern California said during a press conference on Tuesday afternoon, the instrument has identified methane plumes from so-called super-emitters, which already include a plume at least 3 miles, that's 4.8 kilometres long, in the sky above an Iranian landfill. This newfound super-emitter is pumping out 18,700 pounds, that's 8,500 kilograms of methane into the air every hour, researchers said. That's a lot, but it pales into comparison to a cluster of 12 super-emitters EMIT spotted in Turkmenistan, all of them associated with oil and gas infrastructure. Some of those plumes are up to 20 miles, that's 32 kilometres long, and together they're adding about 111,000 pounds, 5,400 kilograms of methane to Earth's atmosphere per hour. That's comparable to the peak rates of the Aliso Canyon leak, one of the largest methane releases in US history, which occurred at Southern California in October 2015, which wasn't fully plugged until February 2016. EMIT spotted all of these super emitters very early during the instrument's checkout phase, so it should make even greater contribution as it gets fully up and running, and scientists gain more familiarity with the instrument's capabilities, team members said. Andrew Thorpe, a researcher technologist at JPL, said recently, "We're really excited about EMIT's potential for reducing emissions from human activity by pinpointing these emission sources." And that's all we have time for in this episode of Astronomy Daily. Thank you for joining us again, and our regular reminder that you can find all the episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson, as well as every episode of the podcast Astronomy Daily at this address, spacenuts.io. So head over there and click the links and you'll find everything for your fill of space, science and stuff. And we'd love to see your comments on our Facebook page as well. So go to this one on Facebook. It's the Space Nuts Podcast Group, and you can meet the worldwide gang there. I'm Steve Dunkley, manning the shop while Andrew is on the other side of the world, having fun, I hope. And Halley, in the words of the T-1000, I'll be back.
Oh wow, Arnold Schwarzenegger. He's so dreamy.
Hey, what's so cool about Arnold Schwarzenegger, Halley?
You know, the shiny titanium chrome exoskeleton and the glowing red eyes. Totally dreamy. What's not to love?
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.